Hey everyone, in this video I want to show you how you can make a yield sign on Desmos. What we're going to get out of this series, there's going to be multiple parts because there's a lot to explain. We're going to get rounded vertices, and we're going to get straight lines connecting the three vertices. And the reason it's going to take multiple parts is because we need to first define the circles needed for each of the vertices, and then we also need to ensure a smooth transition between the circles that we draw and the line that it leads up to. First, we're going to define a few variables. I'm going to use quotation marks to comment what each of these variables are. Now let's start with the size of each of the circles. So for that, I'm going to call this R0. And then we're going to have a variable for the distance from the center of that triangle. This is not necessarily the centroid. I'm just talking about the origin. So in fact, let's call it that instead. So now let's define each of our vertices. And notice that I'm already putting parentheses around the x-axis because we already know that these vertices aren't going to be at the center. We need to move them somewhere anyways. This is plus y squared. Since we need 3 of these, you just duplicate them, and then we can figure out where they're going to go. Alright, now we're going to calculate where each of these vertices are going to go. I want to assume an equilateral triangle on the yield sign. If you want to take this really simple, we can go isosceles where we take the middle point straight down. Here, in fact, I'll show you how to get yourself an isosceles triangle. You grab one of these and say, I want to move this y point down by R1 units. And then this has to be 45 degrees from this line here. And so for that, we're going to go minus R1 cosine. This is 45 degrees. Pi gets you 180. Pi over 2 gets you 90. So this has to be pi over 4. This is minus R1 sine of pi over 4. And then for this one, we just do it slightly different. In fact, we just replace it with the equation below, and it makes a plus. And there you already have a customizable size for yield sign. But for this video, I'm going to show you how you can also do an equilateral triangle, which is slightly more involved. First off, let's delete these. Now the angles inside of each triangle is 60 degrees, but since we're going about from the outside, we need to calculate 120 degrees instead. And it's not 120 degrees from this horizontal line here. We want 120 degrees from this vertical line here. And so going counterclockwise 9 degrees, that leaves us with 30 degrees left, which means for the first vertex, we should be calculating 30 degrees from here. And so to get 30 degrees, we still need to know the distance. We still need the cosine component. This is going to be pi over 6. And then this y is also going to be r sub 1 sine of pi over 6. And now I need to calculate the distance from here, from this horizontal line, over to his next quadrant. We're already leading 30 degrees, and so if we're going over more counterclockwise, that gets us 150 degrees. But the easier way is to calculate from here, which is 30 degrees from the center, or 30 degrees from this opposing axis. Because going 150 degrees counterclockwise is the same as going 30 degrees clockwise. So for that, we just copy the top equation, and the difference would be making the x part negative instead of positive, or we're going left instead of right. Now for here, we just need to move this down vertically. So this one, we don't need to do any trigonometry. We just need to move this down. R sub 1 sine. We just need to do R sub 1. So technically, we don't even need parentheses around that third equation. And this is still customizable. And we get ourselves the vertices needed for an equilateral triangle. Let me know if you have any questions on how to get these values. I'm going to make a members only video on how these values are computed. And with that said, I'll see you in the next part where we're going to make lines that are perfectly in line with the slope of these circles. And that'll connect the rest of our triangle. Hope you found this video helpful, and I'll see you next video.